We are on to 8-5, which is similar triangles. So here's just some ways to tell if two triangles are similar to each other. So one is that two angles of one triangle are congruent. Remember, that means the same to the two angles of another triangle. So we call that by AA. If you know two angles in a triangle are the same, can you figure out the other angle in that triangle? And will it also be the same? Yeah, it will be. It will be the same. I have two triangles that have 40, let's say they're 40, 40, or two of the angles. Can I figure out the other angle? What would it be? How many angles, how many degrees are in a triangle? 180. How many are already accounted for? 80. So I have how many left? So if I draw a bigger triangle, but it measures the same thing, has the same measurements, it's just bigger, is that third angle still going to be 100? Yes. Okay. So one way to tell similarity, you cannot tell congruence by knowing the angles, because those two triangles are not the same. They're similar, but they're not the same. So just know the difference, okay? The measures of the corresponding side lengths of two triangles are proportional. Shh. Okay? So we call that side, side, side. Shh. The measures of two side lengths of one triangle are proportional to the measures of two corresponding, that's another big term, corresponding side lengths of another triangle, and the included angles are congruent. So that means if you had, like you knew this one was 5, and you knew this one was 6, and you knew this one was 2.5, and this one was 3, those are proportional. 6 is double of 3, 5 is double of 2.5. So that would be side, angle, side. Okay? So do you remember when we were doing rates and proportions and we were doing equivalent fractions? Right? What is 5/10 also equal to? What is 5 over 10 also equal to? 1/2, right? So similar triangles are all about proportions. They're exactly what that is. So the easiest way to deal with similar triangles, I label them. In most triangles, there will be a short side, a medium side, and a long side. I just tend to think of them as small, medium, large. And if you label those ahead of time, it makes your comparing much easier. Okay? The only exception to that will be when you have an isosceles triangle when two sides are the same length, or if you have what's called an equilateral triangle where all the sides are the same length. But most triangles, there's a long side, a medium side, and a short side. Okay, so let's just label those here. So, let's pick on some. Emily, which one is, in this ABC triangle, which one's your short side? What's the smallest length? Just tell me the number. 6, right? That's your small side. What's your medium side? And what's your long side? 10. Okay, now do it in the other triangle. Which one's your short side? 9. Your medium? And your long. Good. So all you're going to do now is compare short to short, medium to medium, long to long. Okay? So, and if they're proportional, they will all reduce to the same ratio. If similar, they have the same ratio. All right, so we're going to do short to short first. So Emily, what's your short side of your little triangle? 6. And what's the short side of your long triangle? 9. And what does that reduce to? What's a number that can go into 6 and 9? So Emily, what's a number that can go into 6 and 9? 3. And how many times does it go into 6? 2. And how many times does it go into 9? 3. So if this triangle is similar, then my medium sides and my large sides will also reduce to that 2/3. Okay, so this is what we're looking for. So, Rachel, let's do the medium side. So, what's the medium side of the short triangle? 8. And what's the medium side of the big triangle? 12. And what does 8 over 12 reduce to? 2/3. So far we're okay. You want to go ahead and do the long side, Rachel? Okay, so what's the long side of the little triangle? And what's the long side of the big triangle? And what is 10 over 15 reduced to? 2/3. If I get all three are the same proportion, that is a similar triangle. Okay? Make sense? So I'm going to show you another way to do that, where you can just go with what you have here. What you have to be careful about is making sure you're comparing similar sides. Okay? For this set of triangles, you've got a side, an angle, and a side. You have a side, the angle between them, and the side. So when I say this angle in between them, I mean this angle is created when you put those two lines together. Okay? So another way you can do that is in the M, you can do the ratio of, let's say on this one, it's the left side to the bottom and then the left side to the bottom here. So for triangle MNP, Jace, what's your left side of that triangle? 3, and what's the bottom side of that triangle? 6. What does that reduce to? 1/2. So if these are similar triangles, then that has to reduce to the same fraction. So what's the left side of the big triangle? So that's triangle QRS. And when you label triangles, you have to go in the same order. So if we went top, left, right, you have to go top, left, right. Okay? So what's the left side? 4. And what's the bottom side? 8. And what does that reduce to? 1/2. So because those ratios are the same, those are similar triangles. Okay? Let's see. I'm just going to pick a couple of these. We're not going to do all of them. Tie number, let's do number 2. I also think in geometry, sometimes it helps to redraw your pictures a little bit. This is given to you like that, but it's flipped around from this picture. So I think it's just as easy to redraw that and make it face the right direction. So Ty, how long is this, the bottom part of that triangle? I just flipped it over. 24, good. Do you know this side? What's that side called? It's directly across from the right angle. What's that side called? Hypotenuse. So how long is this vertical side over here? 18. Okay? So once you do that, you don't really need this one anymore. I think it's easier to compare. The easiest way to do that is pick a ratio and reduce them and see if you can get them to reduce to the same thing. So Ty, you have a choice. You can either do right side over bottom or bottom over right side, whichever, for both triangles, or you can compare the short sides to the long and then compare the long sides. If they reduce to the same fraction, you're good to go. So which one do you want to do? Do you want to compare within the triangle or triangle to triangle? Okay, so we're going to do the right side to the right side. So what's the right side of this triangle? 20. And what's the right side of the little triangle? And what does that reduce to? You have to reduce these fractions to see if they are similar or not. What number goes into 20 and 18? 2. How many times does it go into 20? And how many times does it go into 18? 9. Okay? So that's what we're aiming for over here. So now we're going to do bottom and bottom. So what's the bottom of this triangle? 36. What's the bottom of this triangle? What's the biggest number that can go into 36 and 24? Not the biggest, but we'll use it. How many times does it go into 36? And how many times does it go into 24? 4 times. Am I all the way reduced yet? Okay. What can 6 over 4 reduce to? 3/2. Is 3/2 the same thing as 10/9? Nope. Doesn't reduce to the same thing. So these are not similar triangles. a way that you can look at these. If they're set up where they're just looking, they're drawn the same direction, you have left side angle, bottom side, left side angle, bottom side. You can just look at that. How do you get from 8 to 4? And ratios are always by multiplication or division. So, Marisol, how do you get from 8 to 4? By what? Huh? You multiply 4 by 2, or you multiply 8 by a half, right? So 4 times 2 is 8. What's 9 times 2? So those are similar triangles. The ratio is the same. Okay? 4 times 2 equals 8. 9 times 2 equals 18. So those are similar triangles because the ratio is the same. Remember, all a similar triangle is that I just enlarged it or I shrunk it down. Okay? When you take pictures and you get an enlargement of a picture, regular picture is a 4 by 6 picture, but you can get a 5 by 7, you can get an 8 by 10, right? When you get those pictures made, sometimes they will tell you it's not a direct ratio from like 4 to 6 and 5 to 7. It's close, but it's not exact. So if you print out a 4 by 6 and a 5 by 7, it won't come out exactly the same picture. Some of your edge might be gone on the 5 by 7 because it doesn't enlarge exactly the same way. All right, flip it over, please. All right, oh, I wanted to do this one down here because you have some on your con that look like this. So, Dylan, so what I would advise when you get these kind of problems is I would redraw your triangles and draw them separately, okay? Some of you have already done this on con. So I would draw the little triangle and then draw the big triangle. And then just rewrite your amounts, okay? So, Dylan, for the little triangle, how long is this side? Shh. 30. What about the bottom? 32. Do you need to know how long this part is right here? Shh, girls. You don't need to know, right? Because we're looking for x. Okay, what about in the big triangle? Now, how long is that side? How are you going to figure that out? Because I need this whole length right here. How long is the first part of it? How long is the second part of it? 10. So you're going to add those two together. So what's the length of that whole triangle? 40. Okay, so this one's 40. How long is this bottom part? How long is this part? How long is that part? Right, so how am I going to write that as an expression? When I have two segments, what did we do over here to get 40? What did you do? You added 30 plus 10, right? So over here, you're going to add 32 plus x. So now we got to figure out how we're going to solve that. And everybody needs to pay attention to this really closely, okay? So let's write our ratio as 30 over 40 equals, what are the bottom lengths, Dylan? So these are our top lengths. What? 32 over what? Plus x, okay? Any proportion, how can you solve it? By cross multiplying. So I'm going to put this on pause, and I want everybody to write out first what you're going to multiply together. I'm so glad you third period people do not have to suffer through the pain that first period just went through to get Ashley to do that correctly. Okay, now Brittany's going to solve it for us. For that con skill, this is your go-to of how to solve that. Okay? So that's it.